All right, we're going to continue comparing the means of two populations. So we're going to test claims when we're comparing the mean of two population. Now, to do that comparison, we're going to be working with independent samples. However, we do not know the standard deviation of each population. In other words, I don't know sigma 1, I don't know sigma 2, I don't. Okay, and when that happens, you have to be very careful. You need to check some extra information. What you need to check? You need to check something about the variance of each population. And sometimes the variance, we're going to assume the variance are going to be equal, and sometimes they're not going to be equal. In this example, I'm assuming the variance of each population are equal. Okay, and here's a problem. And I'm going to read it out loud. They say a manufacturer claims that the calling range in feet of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. You perform a study using 14 randomly selected phones from the manufacturer and 16 randomly selected similar phones from its competitor. The results are shown below in this table. At alpha equal 0.05, can you support the manufacturer's claim? Assume the populations are normally distributed and the population variances are equal. So when you're working with these type of problems, independent samples, we do not know the standard deviation of each population, and we know that the variance of each population are equal. You're following these steps here. Okay, and step number one is to just verify what I just said. Okay, so you're going to check all of these things here. So do I know sigma 1 and sigma 2? Do I know the standard deviation of the populations? No. Okay, nowhere here says how much is the standard deviation of each population. It doesn't say it. Okay, and the next thing I need to check if the samples are random. Yes, because you can see here they use the word randomly selected. Okay, the next thing you need to check if the samples are independent. In this case, in this scenario, yes. Why? Because we're working with, in this problem, we're dealing with two different telephone companies. Okay, so what happens in one telephone company has to do nothing at all with the other telephone company. Okay, and the last thing you need to check is if the populations of telephones are normally distributed, and that's what's said in the last sentence. Assume the populations are normally distributed. And when you do not know sigma 1 and sigma 2, make sure that somewhere here it says the variance of each population are equal, and it does. Look, it says it right there. So we did step 1. Step 2, we're gonna underline the claim and we're gonna write it mathematically. The claim was in the first sentence, and what was the claim? That the calling range in feet, the average distance of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. So we're comparing the mean distance of these cordless phone, and the claim says that the mean distance of the first phone in general is greater than the mean distance of the other company, the competitor. Okay, and that's how we write it. Don't forget, after you translate the claim from words into math, you have to put in parentheses the word claim. Also, don't forget that every claim has a counterclaim, so we need to state the opposite of this claim, mu1 bigger than mu2. So the opposite will be mu1 is less than or equal than mu2. Now that's the opposite of this original claim. However, in our book, in my stat lab, the counterclaim here, we're not going to use less than or equal. Instead, we're going to use equal. Okay, now we're going to label our claims as HO and H1 or HA. So the claim with the equal is HO. The claim without the equal is going to be H1 or HA. I'm going to use H1 because that's how we do it in my stat lab. And look, I did step number 2 here. Okay, that's this step. Now we go step 3. What is step 3? We're going to find the level significance. In other words, how much is alpha? And you can see here, alpha is 0.05. And we did step number 3. Step number 4, we're going to find the degrees of freedom. Okay, and how do we find the degrees of freedom? You can see the formula here. Okay, I'm going to type it instead of write it. So df is going to be N1. Who's my N1? 14 plus, because that's what it says there in the formula, plus N2, 16, take away 2. And when you work this out, you're going to get 28. And that is my degrees of freedom. And I did step number 4. Step number 5, we're going to do the picture, the bell-shaped curve. Okay, so this is step 5. The bell-shaped curve. We need to shape one tail or both tails. Okay, who decide that? H1. Always. And I have the greater than symbol, the right arrow, so I'm shading the right tail, see? And that's it. That's step number 5. Step number 6, that's when we find what is called the test statistic, which is a number that we're going to calculate using this formula. I know the formula looks intimidating, but let's plug in, because that's what we do with formulas, okay? So I'm going to plug in. Let's start with the first parenthesis, x bar 1. I'm going to type it instead of write it. X bar 1 is 1275. Take away X bar 2, that's 1250. Okay, we're going to close the parentheses. And then I'm going to subtract mu1 minus mu2. Now, because we always assume that the mean of each population is equal, if the mean of each population is equal, and when I subtract that, I'm going to get 0. So that's why I'm going to put 0 here. Then I had 2 square roots on the bottom. Let's work with the first one. Okay, so I had 2 fraction bars here inside the first square root. And in the first fraction, I had the parentheses n1 minus 1. And who's my n1? 14. Take away 1. Okay, oop, I think I did something wrong. Let me fix that. Hold on a second. Let me erase what I did, because I was looking at the wrong radical. I'm in the first radical here. So I'm going to have a long fraction bar here. Okay, I'm in the first radical. So in my first parentheses, I have n1 minus 1. So I have 14 minus 1. Close the parentheses. And I'm going to multiply that by S1 square. I'm sorry, S1, which is 45. And I'm going to square that. Then plus, now I'm going to do n minus n2 minus 1. So who's my n2? My n2 is 16 minus 1. Okay. And I'm going to close the parentheses here. This is a parentheses also. And who I'm going to multiply that by S2, but I'm going to square S2. Okay, and then I'm going to divide that by N1 plus N2 minus 2, which really looks like the degrees of freedom. So 14 plus 16 minus 2, that's basically the degrees of freedom that we did in step 4. Now, that was the first radical. Now I'm going to multiply that radical by another radical, another square root, which I have inside 1 over N1, so 1 over 14, plus 1 over N2. And who's my N2? 16. I know it's a long formula, just plug in. And now codecimals calculator. That's what I'm going to do. Here's my decimal calculator. I suggest you do that here. I'm looking for the place to type this in here so you can see. I'm going to type all of this in my calculator, fraction, parentheses, 1275 minus 1250, close the parentheses, minus 0. Now we're going to work on the bottom. We have 2 radicals. Okay, so let's work in the first radical. I have a fraction inside. I'm going to have 14 minus 1, close the parentheses, 45 times 45 squared, plus another parenthesis, 16 minus 1, close the parentheses, times 30 squared. And then on the bottom here, I have 14 plus 16 minus 2. That was the first radical. Okay. Now I move the cursor outside the first radical. I'm going to click the second radical. Careful how you type this. Okay. And inside there I had two fractions. So the first one is 1 over 14 plus 1 over 16. And you see I typed everything I wrote here, I type it there. Okay, always check that it looks the same. And look, I got my t, my test statistic is usually 2 decimal places. So this will be t equal 1 point, and I missed the rest. 1.81. Okay, and there is my t, and I did step number 6. Now we're gonna do step 7. Find the p-value. How do we find the p-value? Well, look at the formula. It started with t. Okay, and in t, that means that we're gonna be using the t calculator. Okay, and we're gonna fill in these 2 boxes. The link for this calculator is in the lecture notes, so make sure you get it. All right. What is my degrees of freedom? 28. What was my t-value? 1.81. Calculate, and you're gonna get 3 answers. Now, which answer you're gonna choose? See the 3 answers? It all depends on your picture. So I have one tail to the right, so that will be the first one. And look, this is my p-value. Oops, only the first number, okay? I need to round to 3 decimal places. So step number 7, it will be the p-value. And what I'm gonna do is round to 3 decimal places. So 0.041, okay? 0.041. And I did step number 7. Now we're going step 8. Okay, that's when we make the decision. How do you make the decision? You compare the p-value against the alpha. Okay, the p-value we already did in step 7, 0.041. Your alpha, that was step number 3, 0.05. From left to right, the p-value is bigger or smaller than alpha. Is smaller. And according to this chart, when the p-value is smaller, what are we going to say? We're going to say reject HO. And I did step number 8. Now we're going to do step number 9. Okay? And that's when we make the interpretation. How? Using this chart. You need 2 things. Your decision. Well, my decision, step 8, was to reject HO. So I'm in the first row. And I need, where is the claim? That's what I ask you to put in parentheses, the word claim. And the word claim is in H1, so I'm in the last column. And look for the intersection on the first row and last column. And look what it says. There is enough evidence to support the claim. And that's what I'm going to type. Enough to support the claim. What claim? That the the cordless telephone of the first company, the mean distance is greater than the competitor. All right. I hope this helped.